Welcome to today's deep dive. And, what if I told you the absolute hottest, most lucrative commercial real estate in America right now isn't some gleaming Manhattan skyscraper?
Right, or a sprawling tech campus out in Silicon Valley.
Exactly. It is actually a heavily fortified, vibration-proof bunker sitting right in the middle of Indiana.
Yeah, which is just wild to think about.
It really is, because for those of you listening, we often think of commercial real estate as this relatively static world.
Yeah.
You picture a suburban office park or a distribution warehouse off the highway, or maybe just a retail strip mall.
Yeah, we tend to treat these spaces as just simple passive containers for businesses to operate inside of.
Right.
I mean, the traditional asset classes are very established.
Yeah.
Historically, it's really just been about having four walls, a roof, a standard HVAC system, and some functional square footage.
Mm-hmm.
The physical structure itself doesn't actively participate in the business. It just houses it.
Well, today we are going to look at how that traditional blueprint is just being completely ripped up. We are taking a deep dive into a really fascinating blog article from Allies Commercial Realty. It's titled Strategic Transformation: How Indiana's $1 baller life science commitment is redefining asset classes.
It's a great piece, really eye-opening.
It is. And our mission for you listening today is to unpack how a massive influx of capital into Indiana is basically turning highly complex specialized laboratories into a brand new asset class.
Yeah, and we'll explore what this means for the future of how commercial space is built and leased and ultimately valued.
So to kick things off, let's just look at the sheer scale of what is happening here. Because in March of 2026, Indiana's governor, Mike Braun, announced a $1 billion performance-based investment.
Which is a huge number.
Massive. And the explicit goal there is creating 100,000 high-wage jobs over 10 years. They are specifically targeting human therapeutics, animal health, agri-tech, and biotech.
Yeah, and $1 billion of public-private alignment. I mean, that sends a massive signal to developers and investors.
Yeah.
But the framing of this announcement is really critical to understand.
Yeah, so
Well, this wasn't it wasn't the initial spark trying to ignite a brand new industry in the Midwest.
Yeah.
It was basically high-octane fuel being poured onto an engine that was already running at redline.
Oh, I love that. It's like treating Indiana like a new life sciences market is like calling a band an overnight success when they've secretly been, selling out stadiums for a decade.
Exactly. That's a perfect way to put it, because the source material highlights a statistic that just forces complete recalibration of how we view this whole industry.
Right, the California stat.
Yes.
Yeah.
In 2024, Indiana actually surpassed California to become the #1 life sciences exporter in the United States.
Wait, really? They beat California?
They did, which is crazy, right? Because we are deeply conditioned to view Boston or the San Francisco Bay Area as the undisputed centers of gravity for biotech.
Yeah, absolutely.
Yet the data shows Indiana's life sciences sector is already generating $99 billion in economic activity. Yeah, with a $102 billion annual impact on the state's economy, you have 3,300 companies and 70,000 employees operating within this specific ecosystem.
That is just staggering. And when you look at the metro level, the Indianapolis area actually ranks 4th nationally for pharmaceutical employment.
Right. It's a massive hub.
Let's just look at the global anchors driving this critical mass. You have Eli Lilly advancing a staggering $9 billion active pharmaceutical ingredient facility.
$9 billion. Just huge.
Plus a $4.5 billion Lilly Medicine Foundry in Lebanon, Indiana. Then Roche Diagnostics is advancing a $550 million facility right in Indianapolis.
Yep.
And then you layer in Novartis, Elanco Animal Health, Corteva Agriscience, and Cook Medical. The output from all this density is just massive. Over 100 FDA approvals and 926 new patents recorded in 2024 alone.
And that's the key right there. Those 100 FDA approvals and 900 plus patents, they represent a massive pipeline of physical workflows.
Right, because they aren't just ideas.
Exactly. A new biologic drug or a diagnostic tool doesn't just exist on paper. It has to go through rigorous bench research, preclinical testing, highly controlled manufacturing, and global distribution.
So they need actual physical space.
Yeah, the physical infrastructure required to support that entire life cycle is where the traditional real estate equation completely breaks down.
I mean, trying to put a modern biotech lab into a standard corporate office, it's like trying to run a commercial data center off a residential breaker box.
That is exactly what it's like.
The physical skeleton of the building literally cannot carry the required voltage or the weight or the safety parameters.
Right.
Let's dig into the architecture of innovation, starting with the baseline requirement, which is wet labs. Because a wet lab isn't just, a room with wipeable counters.
No, not at all.
These spaces require integrated, highly secure chemical storage. They need specialized gas lines piped directly through the walls to specific workstations and dedicated cold storage units that operate at ultra-low temperatures.
Yeah, and the mechanical, electrical, and plumbing systems, what we call the MEP, have to be engineered to an entirely different standard.
Right, the MEP is totally different.
Because a standard office building, it simply recirculates air to keep the ambient temperature comfortable for humans. But a life sciences facility often requires 100% outside air exhaust systems.
Yeah, 100%.
Yeah. Take a fume hood, for example. It is not just a fan. It requires dedicated exhaust shafts that can never, ever mingle with the rest of the building's air supply.
Oh, because of contamination.
Exactly. This means you are routing massive ductwork all the way to the roof. You are fundamentally losing rentable square footage on every single floor just to keep the building safe and compliant.
And the power demands to run those systems, along with the incubators and centrifuges, have to be astronomical.
Oh, they are.
I mean, if a standard office loses power for an hour, people just, stop typing and go get coffee.
Right, it's an inconvenience.
But if a life sciences facility working with delicate therapeutics experiences even a slight fluctuation in temperature or humidity or air purity, millions of dollars of research or even clinical trial supplies are instantly ruined.
Yeah, it's catastrophic. The building has to be capable of powering itself seamlessly through uninterrupted power supplies and massive backup generators.
Okay, so that's power and air. What about the actual building structure?
Well, we also have to look at the structural engineering. The literal physical skeleton of the building changes.
How so?
A standard commercial second floor is just not engineered to hold the sheer dead weight of massive autoclaves or densely packed liquid nitrogen tanks. The load-bearing capacity of the floors must be significantly heavier.
I would imagine vibration control plays a massive role in that structural engineering as well, right?
Oh, absolutely. It's a huge factor.
Because if a researcher is calibrating a highly sensitive instrument or using a scanning electron microscope, a delivery truck hitting a pothole outside could essentially act like a localized earthquake.
Right. It could blur the image or throw off a micro-measurement completely.
So how do they fix that?
Developers have to pour specialized slab-on-grade foundations. Or they mechanically isolate specific sections of the floor just to dampen those microvibrations.
That sounds intense.
It is. And then you layer on strict biosafety level compliances, mandatory emergency infrastructure like continuous flow eye wash stations, and purified water systems that require their own dedicated filtration rooms.
Jeez.
You are basically building a highly regulated operational machine.
Okay, but here's the financing piece that fascinates me. The source notes that these specialized lab environments require capital investments of $200 to $400 per square foot just for the interior build-out.
Yeah, $400 a foot is not uncommon.
With commercial real estate currently facing incredibly tight lending environments and high interest rates, developers must be facing intense scrutiny from banks.
Oh, they definitely are.
Right, so at $400 a square foot, the capitalization rates on these buildings must be incredibly sensitive. How are developers convincing lenders to finance these massive hybrid spaces when traditional office real estate is, struggling just to refinance?
That's the billion-dollar question. And the financing is secured because this asset class fundamentally alters the risk profile.
How?
Through something called tenant stickiness.
Tenant stickiness.
Think about it. If a landlord or a business drops $300 a square foot, customizing a clean room with dedicated exhaust shafts and vibration-isolated floors, that tenant is not moving out when a standard 3-year lease expires.
Oh, right, because they'd have to build it all over again somewhere else.
Exactly. The friction and cost of relocating are just far too high.
So spending that much capital upfront creates a scenario where both the landlord and the tenant are basically locked in for the long haul.
They commit to much longer leases. We're talking often 10 to 15 years. And for an institutional real estate investor or a lending bank, that represents the holy grail of commercial property. It's stable, durable, long-term occupancy with highly predictable income streams.
That makes a lot of sense. And I guess the creditworthiness of the tenant is also drastically different from your standard commercial renter, right?
Oh, completely different. These life science occupiers aren't risky early-stage ventures just bootstrapping their rent out of a garage.
Right.
The Allies commercial realty piece points out they are typically backed by massive venture capital funds, or they are integrated into pharmaceutical giants, or supported by significant government grants.
So the default risk drops significantly.
Exactly, especially when the lease is guaranteed by a multi-billion-dollar pharmaceutical pipeline.
And the nature of what these tenants need under one roof is evolving too, isn't it? Companies no longer want their research teams isolated from their executives or their manufacturing arms.
Right, the siloed approach is dying out.
We are seeing a massive shift toward hybrid space requirements. A single facility must incorporate traditional administrative offices, highly technical R&D wet labs, and light manufacturing space to actually produce the therapeutics.
Consolidating those functions really accelerates their speed to market. And it also forces these hybrid facilities to cluster together.
Oh, because of supply chains.
Exactly. You want to be near your suppliers, near hospitals for clinical trials, and frankly, near the talent pool.
That makes sense. The source actually identifies specific submarkets in Indiana that are absorbing this demand.
Yeah, there are a few key areas.
Like Fishers along the I-69 corridor, that is becoming a magnet for mid-sized life sciences companies. Then downtown Indianapolis and the 16 Tech Innovation District are capturing early-stage biotech and health tech due to the immediate proximity to major research hospitals.
Yeah.
And then, of course, Boone County and Lebanon are being entirely reshaped by the broader LEA District build-out and Eli Lilly's massive footprint.
And that clustering in areas like Lebanon triggers a massive multiplier effect across the entire local real estate market.
The multiplier effect, can you explain that for the listeners?
Sure. When an entity like Eli Lilly invests $9 billion in a manufacturing hub, they do not operate in a vacuum. They require an army of specialized suppliers, cold chain logistics firms, and legal and research partners.
Right, the whole ecosystem.
Exactly. All of those secondary businesses need to be positioned near the epicenter or near established talent pipelines like Purdue University and Indiana University.
Because they aren't bringing their entire supply chain with them from somewhere else, right? They are outsourcing locally.
Yes, and this localized demand forces aggressive absorption across the surrounding area.
And just for anyone listening outside the real estate sector, absorption is simply the rate at which available commercial space gets leased up or sold.
Right. So this multiplier effect means these secondary companies are rapidly eating up local industrial parks and flex space.
Flex space being those versatile warehouse-style buildings that can easily be divided into part office and part light industrial.
Exactly. It drives up location-specific property values across all asset classes.
Yeah.
Meanwhile, traditional single-use office buildings in those same submarkets face growing obsolescence if they cannot adapt to this hybrid, high-demand ecosystem.
Wow. So because this ecosystem is so dense and the physical requirements are so extreme, the actual process of securing a lease becomes this strategic minefield.
Oh, it really does.
A rapidly growing biotech startup cannot simply browse a commercial listing website, tour a building, and sign a standard lease. The role of the real estate broker has completely transformed here.
It has. The traditional commercial broker is largely transactional, right? They match a tenant with available square footage and negotiate a standard rate.
Sure.
But in the life sciences sector, the broker has to execute a highly specialized strategy. Site selection alone is an intricate puzzle. Well, a broker isn't just looking at the floor plan. They have to verify the municipal infrastructure. Does this specific parcel of land actually have the redundant power grid capacity the lab will demand?
Oh, I hadn't even thought of that. They also have to navigate zoning constraints, right?
Absolutely.
Because a standard commercial office never has to worry about local ordinances regarding biological materials or chemical waste disposal or heavy manufacturing emissions.
Right. A strategic broker has to ensure the site is legally zoned for the specific science the company intends to conduct.
And furthermore, they have to evaluate scalability. If a company's drug gets fast-tracked for FDA approval, can the physical site accommodate a rapid expansion of the light manufacturing footprint, or are they just landlocked?
Exactly. And the lease agreements themselves are vastly more complex than a traditional commercial contract.
I would assume so, yeah.
The negotiations center around massive tenant improvement allowances. The broker has to meticulously negotiate how that $400 per square foot build-out cost is divided between the landlord and the tenant.
Right, because no one wants to foot that whole bill.
Exactly. They must establish specialized equipment provisions, determining who is legally liable for maintaining the dedicated exhaust shafts or the purified water systems over a 10-year term.
That sounds less like renting an apartment and more like negotiating an international trade treaty.
It really is.
The source also highlights the necessity of navigating public funding, which is huge. Brokers are often the critical link in securing incentives from the Indiana Economic Development Corporation, the IEDC, or navigating REDI grants.
Yeah, the REDI grants are crucial.
Right, the Regional Economic Acceleration and Development Initiative. It's a state-level program designed to inject public funds into local infrastructure. These grants can offset those astronomical capital expenditures, but securing them requires complex bureaucratic maneuvering and perfect timing.
And timing is perhaps the most ruthless variable in this entire equation.
Really? Why is that?
Well, in a supply-constrained market where specialized lab space is scarce, a life science company cannot afford a reactive real estate strategy. Their operational timelines are directly chained to their funding cycles and their product development milestones.
Okay, so if a venture capital firm mandates that a startup must reach a specific phase 2 clinical trial milestone by, say, the third quarter to unlock their next round of funding, that deadline is absolute.
It is entirely absolute.
So if that company is delayed by 6 months because they couldn't secure a facility with the correct HVAC certification or they got bogged down in zoning disputes, they don't just face a minor logistical headache.
No, the venture capital funding dries up, the research stalls, the commercialization of a potentially life-saving therapeutic just derails.
That is brutal.
It is. A strategic broker with cross-asset expertise prevents this by aligning site selection, complex lease structuring, and public grant applications into one cohesive timeline that actually protects the science.
Wow. Okay, to synthesize this for you listening, Indiana is not an emerging player trying to break into the life sciences sector.
Yeah, I don't know.
It is a mature $100 billion juggernaut that has firmly established itself as a global reshoring epicenter. Governor Braun's $1 billion investment is just pouring fuel onto a highly developed engine.
Exactly.
And because the physical demands of creating modern therapeutics and biotech are so intense, requiring these fortress-like structures with dedicated power grids, vibration-proof floors, and strict contamination controls, commercial real estate has been forced to fundamentally evolve.
Right. It's birthed a highly lucrative, heavily specialized asset class defined by long-term tenant stickiness and backed by institutional capital.
Yeah, and navigating this new landscape requires shifting from basic transactional real estate deals to high-level strategic execution. Securing the right physical space is quite literally the difference between launching a breakthrough drug and losing your funding entirely.
And you know, the scale of this transformation leaves us with a profound implication to consider.
What's
We are watching the creation of highly resilient, self-sufficient, hybrid facilities that operate almost like mini cities. They feature their own redundant power grids, their own advanced waste management protocols, and their own purified water infrastructure.
Right.
So if the industry continues to cluster and expand under this massive $1 billion initiative, how will placing these immense new technological and physical demands onto the civic grid fundamentally redesign the blueprint of Indiana's surrounding residential neighborhoods and municipal infrastructure over the next decade?
That is a fascinating question. The cities themselves are going to have to adapt just as radically as the buildings have.
Yeah, it's going to be wild to watch.
It is a fascinating ripple effect to track. Well, thank you for taking this deep dive with us today. For everyone listening, keep looking closely at the spaces around you. The invisible forces dictating how they are built and who occupies them are way more complex and more powerful than you might ever guess. Catch you next time. Get in touch with Allies Commercial Realty at info@alliescommercialrealty.com to find your ally in commercial real estate.